All right. So, thank you all for being here. Um, the topic today is V2X, which our
Okay.
guest Maria is going to explain to us. So, Marie Cooper, how about if you introduce yourself,
Mhm.
describe what you do, and then let's dig in.
Okay. Well, I'm going to start out with a little bit of my background, which is graduate from the University of Michigan, and then I actually kind of stuck around for a while and got added onto a project that was a satellite project that got put into space. So my degree is really just physics and math, and then I got into space physics because of this project, and they liked my analysis of data, and they decided to keep me on as a programmer. And at first, all I did was make a web page. Now, this web page is really funny because it's like made 1990s, I don't know, 96, 97, and it hasn't changed since. But what's funny about it is that you can still, to this day, see data that has come in all the way up until this month, of this year, which is kind of interesting. That something that I worked on, 20 years ago, is still up and running and kicking, and so it gives you kind of a sense of accomplishment when you can work on something that long. But uh, Tidy was very interesting because I even got to have my name in a whole bunch of papers. There's tons of scientific papers that were written on it. And so a lot of it had to do with satellite communication. I had to communicate with the satellite. Um, we had data that was automatically downloaded, but we needed to send commands. And so because of that communication, oh, there's the actual, uh, we sent it up with a rocket. It's called um, a Delta II rocket. And we were piggybacking with a French satellite also so that we could share the costs. Um, and but yeah, so I just wanted to, I mean, I actually got to see and work on things like this. This was the actual instrument. It had four telescopes pointed down, looking at things. It was very neat. We had lots of different science going on with that one. Um, and but because of my communication skills, Denso decided that they were going to hire me. They had different kind of communication though. Their communication was more about cellular communication with the vehicle and getting like if you have an accident, uh, your crash notification would go off, and so your airbag would go off, but then it would automatically call for you. So this was like the first steps of getting safety measures into a car. But also then, there's like a little button that you could press for information, or you could get points of interest downloaded to your, human interface, the screen in your vehicle. So that was what I did for the first 7 years of working for Denso. The other stuff, the science, at University of Michigan, that was like 17 years. So I have a lot of background in that. Very short background on this. 7 years is really not that long. I'm just kind of getting into what we can do with this. Denso is actually a pretty big company. A lot of people don't know what Denso is, and it is a Japanese-based company, but they also have um, lots of facilities around North America and into Canada, well, Canada's North America too. Sorry, um, but but down in Mexico and Canada too. But um, they deal with parts for automotive, and the part that I work in is the um, is V2X now. It was telematics. Another thing to note about Denso, they actually created the QR code. So the QR code that you see everywhere, they are the ones that created it. They probably could uh, have made some money off it had they, trademarked it or something like that, but they did not. They wanted everyone to use it to make it, you know, um, uh, available to everybody so that they could be organized. And I mean, there's just so much information in one QR code, so much better than a bar scanner. Okay, so now I want to, oops, stop sharing that one. And so what I first started doing at Denso was I dealt with like how to track the vehicles, how to, like where are the vehicles, what kind of signal do they have. This was with cell signal, because at first we were looking at cell signal for a while. And that I actually had to, I'm a programmer at heart, truly. And so I actually made a program that would give out output like this, which is cell signal, like as you move through someplace. And I had to be able to figure out how to plot that on something. Well, I made a program for that. And when I made this program, I just thought it was going to be for me, but other people got interested in it. They liked the output. They were like, this looks simple to use. I said, it is simple to use. You just double click on this and everything works. And now it's actually used in all 4 quarters of the hemisphere. I know that because I had to actually go back and reprogram it because I didn't allow for the different quadrants of the sphere. When you look at GPS coordinates, you've got minus, so many latitude, minus so much longitude. Well, if you are on the other side of the globe, you are actually using a different set of satellites. It's not GPS. It's called the Glasnost satellites, which are mainly Russian. And they use a different kind of format. And so I had to allow for all of that. So I had to edit it 3 times because of that. Every time they moved it to a different location, something would go wrong and I would have to fix it. So not so good about long-term planning for that. But since it was supposed to just be my own little thing that I was using to present for people, I think not bad. But okay, so now on to V2X, which I have to, I'm sorry, I thought I had brought that up and I had not yet. Just 1 second. I'm sorry. Here it is.
So,
oops, sorry. Well, yes.
That project. So, what was the goal of that particular project? What was it that they brought to you and asked you for that prompted you to create that?
So basically we had a whole bunch of data, and the data, oh, I think I closed my window. Just 1 second. Oh, here it is. The data that we had was, just numbers. You couldn't see it. There was no visualization tool for it yet. And they were like, well, are you sure that you're driving in low signal area? And where is that low signal area? And how does it switch between one area to the other? When you actually go out of signal and back into signal, what problems happen? And so here I can share this part of it again. So in here, you can see, like, I actually even had, there was a problem, or not problem, but we had a, where it disconnects and then it reconnects. And so I was able to show that our device over and over again, as we went around on this loop, that it would disconnect, reconnect, and be just fine. And I would disconnect through here and even disconnect in little places, and it would show exactly where that happened. And the reason it disconnected was because of the signal, because it just dropped down too much. So it was a difficult, or not difficult thing, but an easy thing for me to do because of my past experience at U of M with the satellite data. We had done tons of GPS coordinate type of things with Tidy, which was, the satellite that or the satellite instrument that I was working with. We had to plot winds and currents going through the atmosphere, different things, and it was on a global map. So for me, it was a little easier to figure this out than maybe somebody else. So I think that was one of the reasons why they actually brought me in, is because they were kind of at a loss with some of this GPS data that they were looking at. They didn't have anybody who had a strong background in that. and I did, and then I showed this at a meeting, and this got passed around, and then people were like, "We want this. We want to be able to show our data this way too." And so it just kind of, but that was the solution, based on years of, figuring out things from the past or from the past. It doesn't matter what job you have, the science always will help you out, and you can figure things out. For me, also it includes the computer programming. That just seems to always be a part of it. So, but like I said, onto V2X. I'm gonna stop sharing this one. Oops. And share the other one. So V2X, it's basically it's vehicle to everything is what X is. It's anything you can think of. It's vehicle to a stoplight, vehicle to another vehicle to maybe a traffic light, or a crosswalk, or even just the vehicle itself can sense when there are pedestrians about to cross. Things like that, where you get feedback from that. The computer can react faster than you can warn you, can bring up things. We already have this in a lot of vehicles. If you look at higher end vehicles, they'll have it already, like a lane assist, where it actually even will look and see what the edges of the lanes are and make sure that you are within those things. Otherwise, it will give you a warning that you're drifting out of the lane, or might even help you steer and correct into it. But the history of it was like, for our vehicle communications, we actually started out kind of cell phone, thing. And then we also did cell phone communication in the vehicle using these things called TCUs, telematic units. And they are control units. That's what TCU means. And they had different models, ones with exterior antennas that would actually be outside the car, and then some that had interior antennas, kind of, as the technology improved. But now we are using mostly this DSRC, which is like a radio, it's radio communication. And it's so much faster than faster response time to go from one to the other than you would go for in a cell and then get the message back from a cell. Cell is fast, but it's faster with this communication, and that's safer in terms of automotive. The only problem where it actually fails is if you are in a big city and there's lots of traffic. Those communications can be so just bombarding that then you get lag between it, because you've got too many messages coming in and too many messages trying to go back out. So that's where it kind of tends to not be as good as the cellular, but otherwise it's definitely better communication. So people are like, well, why do you even need this vehicle communication? I already kind of mentioned some of the things about the lane assist and stuff like that. It's safety. 45,000 deaths last year alone for driving. And if you can get more and more of these vehicles that can think for themselves or help you to make the right decision, then we'll save lots of money, lots of lives, and that's good. So there's all sorts of different kinds of communication. GPS is different than the roadside communication, which is different than the neighboring vehicles and stuff like that, with a lot of sensors also involved. But there are different applications that you can have with, or different things that you can do with V2X. Forward collision warning, lots of different things, blind spot warning, lane change warning, lots of things that you would think of. And then there's also where maybe things that you wouldn't think of, like dynamic eco lanes, meaning like where if you, these lanes would be where everybody's traveling at the same speed, the same whatever. And so then you're actually conserving fuel too. It's like if everybody was like acting like a train almost. There's different scenarios. I'm trying to think of them right now, and I just can't right now. But like even like you're coming into a curve, the vehicle is told, by a roadside unit that this curve is going to be very sharp, and that your vehicle is going too fast. So then it would warn the driver, hey, there's a dangerous curve coming up ahead. So before you even get there, so especially if it's at night, it's rainy, you're going too fast, it'll tell you to slow up before you come to it, which I think that is very cool. Red
That's
light
amazing.
warnings. What?
I said that's amazing, right? That's
Yes.
great stuff.
Yes. Yeah. So things like that, it's just very cool. And bridge height warnings for trucks, things like that.
So is this in service yet, or is this all still under development?
Actually, there is they set up a little city in near U of M. So in Ann Arbor, Denso was actually part of that, and actually helped them to set up some of the stuff there, some of the roadside units, and then they have a couple of onboard units. So it's like RSU and OBU, onboard units and roadside units. I'm actually doing my concern is mainly with roadside units. So I would actually be working on the actual unit that would be giving the warnings for people to slow down. Here comes the curve, or hey, this bridge is only 13 feet. If you got a rig that's higher, so it would then, but you'd have to have an onboard unit that would have to understand that messaging in order to, be able to be useful. So the roadside units are what the community would have to buy. So like cities would actually invest into a lot of these units, especially on troublesome intersections or troublesome, roads where, a lot of people are going off the road or whatever. That's when they would invest in this. And then it would communicate with the onboard units on a lot of vehicles. The onboard units tend to be very generic. They're very, they can work with many different kinds of roadside units then. So like there's certain standards that you have to follow. There's certain requirements. And then after that, it's, if you wanted to make anything specialized, you would either have to make sure that you have an onboard unit thing that, that people could purchase as an add-on to their vehicle, like with the truck thing, smart roadside. That's not something that would be normally what people would be concerned about, the height of an overpass, but it would definitely be for trucking company. So then they would be able to get those messages too. But onboard units are becoming more and more sophisticated too, and so they'll be
Can I
a lot more.
Can I suggest once it's ready for commercial release, a potentially really big target audience? U-Haul trucks.
Yes, wouldn't that be great?
Yeah, because
I'm sure a lot of them are damaged by people.
I can't even tell you how many large U-Hauls I've seen with the roofs rolled up.
Oh yeah, there was just
Because they don't require a CDL.
No,
right?
they don't. Yeah,
So
which is kind of ridiculous, but hey, they want us to be able to haul our stuff around. So yeah, I mean, I've got some things on here about like there's different kinds of sensors. We have uh, millimeter wave radar, for some of the crash notification type stuff. Rear radar for helping with parking assist. Like you're backing it up and it'll ding if you're about to hit something. But then there's other things that are like more of a like laser sensors and stuff like that for getting distance from here to there, the velocity of something. So there's all sorts of different kinds of sensors that are used in this system, and they're not always equal, but they usually do a certain job. So yeah, so like I said, this is just more of the stuff, the same kind of stuff where one thing that's really neat that I found is the do not pass warning. So like sometimes you can't see around an object, and it'll actually be like with the range that we have right now, it'll actually be able to tell if there's an oncoming car coming. Like even if you can't see, and it should warn you. unless of course it's already in a no pass zone where you're, hills, because you can't see then. Um, but uh, but like it can actually see around a corner, like with the intersection movement assist. Like if you are coming up to an intersection, it can be communicating to the light, pole, or the traffic light, and the other car is also communicating to the light, and it can warn both cars that there's oncoming cars coming. So when more of this stuff is implemented with an actual human driver, then it can also transition into automated driving, fairly easily once it's fully road tested and all the bugs are worked out. Obviously right now automated driving has got a lot of bugs and I would not trust it, but hey, maybe take my hands off the wheel for a little while. But only in certain vehicles. But yeah, so a lot of this stuff though, it's very cool to be working on a team that does this. But like I said, I don't have a lot to do with a lot of the actual sensors that are involved, or the communication with the actual onboard the CAN bus, so that kind of stuff where it actually has vehicle information coming into the onboard unit. And so it can tell, the onboard unit how fast they're moving, how fast, how much they're traveling. And, oh, there is going to be a crash up here if you continue at this speed, type of thing. So, or if you change lanes right now, that kind of a thing. But because I'm more with the roadside units, it's kind of a little different. But one thing that I thought was really cool is it also would be like where emergency vehicles could actually then broadcast that there's emergency, I'm coming through here, and it could change the lights for them, so that there would be less slowdown of the emergency vehicle, and then also less opportunity for any kind of car mishaps happening because the lights are already changing and stopping people. So it's very interesting that things like that. And then also for large vehicles, you can receive information that, yep, you're going to get through that green light, or no, you're not going to get through this green light, so you might as well start slowing down now, and it will save gas. So things like that will also help in long term. But I don't really have a lot more on V2X. If anybody has any questions about my, past with my satellite communication, or if they have any specific questions about this, I can attempt to answer some of them. But V2X is up and coming. It's already being implemented in a lot of different places. I know out in California, they have an entire city that already has a ton of it, but I'm not sure. It's not by Denso, so I'm not sure exactly what all is involved there. But it is starting around here even, and that it will start to spread eventually. As a matter of fact, the city of Southfield might even do a little area with some of the roadside units for testing, which would be cool.
That's very cool.
I have a question.
Yeah, sure.
So I know you said there was like different companies doing, maybe different cities.
Mhm.
So would those devices from different companies be able to communicate with each other at all, or would they?
Yes, because we have a set of standards for the messages and how they need to be formatted, and how the messages like have like identification tags basically. And so that, yes, they would all be able to communicate. Now, if there's something specialized, then no, it might actually be where, you can only get this if you get this onboard unit, that kind of a thing. Okay. So yeah, it just depends. And I'm sure that will get more and more standardized too as we go into the future, because that's exactly what we want. Is we want to have more people and more companies actually working on this problem, because it'll just mean safety for everybody. But yeah, having them communicate is very important. So yeah, we have to kind of stick to the requirements pretty strictly.
Mm-hmm.
So are there standards that are being developed for companies' products to interact that way?
Like I said, there already is a set of standards, so I'm not sure if there's any more, or if there's more talks. That's not something that I can actually speak to, because I'm not really, I said, I've been doing telematics for the past 6 years, and it's only really been this year that I've actually been doing V2X. So I'm really a newbie.
Very
And
cool.
telematics was different. It was through cellular, and it was actually more of a. It was kind of like I'm sure you've heard of GM OnStar. That was the whole system. It was the same kind of system, but with a different set of standards and different head units and stuff. But yeah.
So now you're working with, rather than cell, you had a slide, I think, where you highlighted different types of, right there,
Yeah.
different
Well,
types
yeah,
of
but
communication.
yep. hmm
So
And I don't. Yeah.
how do these different communications media mechanisms, how do they differ from what you've done with cellular data before?
Okay. Well, cellular data, you have to be within a range of a cell tower. And the range of a cell tower can be quite large, especially if there isn't a lot of things in the way, like buildings or trees or hills. Um, but for this kind of communication, it's really uh, it's really not that large. I should have prepared for something like this kind of a question, because I actually we did a study where we actually drove up and down a road near our place, and it would show, okay, this far out we actually can see the roadside unit, and the roadside unit sees us, and then as we drive past it, okay, now we can't see it anymore, and that was about a half a mile, maybe a little more. So that is much smaller than, say, a cell phone coverage, which it can be miles depending on the cell phone tower and everything, and position of it. So you get a much smaller window to be looking at between the two devices, between the roadside unit and the onboard unit. And yeah, so that we were able to determine, though, that about a half a mile was good, from all around it. Now, if you were going up a hill or there was a big building, it would stop immediately. The building is like a blocker. Cell phone, it's not a blocker for the build. A building is, if you're too close to the building, or if the building's really tall, then yes, it can be a blocker. But in general, a building's not really a blocker. But in this case, it doesn't have to be a very big building or structure. It doesn't even have to be a very lot of trees or anything could even block it. So it's not as strong a signal also, and so it can be blocked easier. But when you're looking at roads, and you have a roadside unit and it's like focusing on the road, then you're going to get a longer distance on that road anyways, as long as the road's not really super hilly or anything. But that's the main difference. I mean, there's obviously a difference in the wavelength and all that stuff, and antennas that you need and all that. But the main difference is that, it's a much more reduced coverage.
More focused.
Yeah.
So
you
go ahead.
You
Go ahead.
may have already said this, but I was just curious, is there anything in particular that got you interested in this sort of job? Or
what's funny is I was going to school for physics because I like to know how things worked. My dad was an engineer, and I was like, oh, I'll never be an engineer, and here I am, an engineer. But I just went into physics and math classes because I enjoyed them. At the end, though, I was like, okay, do I want to teach it, or do I want to keep going? And if I keep going, then I would need to do research. And I found a flyer that said research experiences for undergraduates. And it was a summer program at the U of M in Ann Arbor. And I got to go there and work with scientists doing real research. And I absolutely loved it. And when I was done with that summer program, the director of SPERL, Space Physics Research Lab, he came up to me and said, if you apply to grad school here, I will make sure that you get a job to pay for it. Meaning I would be taken on as a research assistant. So that's kind of hard to turn down. But I loved the work. So I was just like, yep, this is what I want to do. And a lot of people can get that same kind of situation where you can actually become a TA for graduate school, um, or a research assistant for graduate school. It's harder when you're as a teenager going into um, college, because there's so much and it's so broad. But if you have a good solid background in science and math, and in math isn't as important, especially now with computers doing the math for you, but with a good understanding of science and how it's applied, and it can really kind of go in any field then. I mean, I was in space physics, and doing climate research, and then now I'm doing communications between vehicles and the automotive field. So totally different, but still using the same kind of problem solving, still using the same kind of programming, and the same kind of science behind it all. So it's been very, very nice that I've been able to make a career out of it.
Cool. Thanks for sharing.
Well, thanks for the interest.
Any questions about how some of these technologies are used here in ways that how do I say this? That they relate to the robotics that you guys do, right?
Oh,
Because
wow.
the communication here, this communication happening between vehicles or between roadside beacons of various sorts, warning of something coming up, are not all that different than the sensor information that is being captured by the robot, and then that it makes its own decisions. So rather than communicating with something else, although it's completely foreseeable that
Right.
first at some point in the future could introduce some challenge where robots can find a way to communicate together, right? I could totally see an opportunity for that to happen at some point. Right now, that doesn't, but you've got
Right.
camera sensors, you've got touch sensors, you've got distance sensors and ultrasonic, and right, there are a handful of FTC legal sensors and inputs. How do you guys see those relating to this sort of communication that's happening here? Marie, any
Well, for me,
comments
I
or
think,
inputs?
yeah, I will say for me, I think that it would relate if you had, just like you said, a challenge where you would be like, say you needed to guide your robot through a maze or whatever, but if you could actually learn from another robot, too, like, I don't know, if you guys could communicate, oh, well, I found a wall over here, I found a wall over there, we're not going to go that way again, or something like that. I can't think of like, because all I can think of is like things like crash avoidance and things like that, because I'm more safety focused. And with robots, yeah, you don't have to be as safety focused, I guess.
Not necessarily, but there are. So for example, this year's game this past year, there were basically cones that were obtained and then placed on various poles, right?
Okay.
So some teams use these sensors to, for example, determine when one of these cones had been was in the appropriate position to grab, and
Oh,
then
okay.
initiate that automatically.
Hmm.
Some of them were able to find creative ways to use sensors, and at least one of them used a camera from an angle that made it a very high probability to line up this yellow pole in a way that it was able to deposit the cone on it. So a lot of these are detection, and rather than avoidance, they're guidance.
Right. I was
But
gonna say it's
it's the
more of a
same idea,
guiding.
right?
Yeah. 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 That is very, very similar because Just like with on here. Oops, on here. I click on the wrong thing. On here where you're trying to line up something. You've got a guide. You're trying to line things up. For backing up a car. Things like that are always happening. Also when you're talking about looking around a corner. On here, like the intersection movement assist, where, oh, I'm coming up to a thing. I don't want to interact with another one, or maybe I do want to interact. Oh, it's right around the corner or something. I mean, I'm not sure exactly how it applies to robots, but yeah, I can see there'd be a interesting application for that. And you said you're not doing it through the DSRC, right? It's all cell.
Say that again.
For robots, isn't the communication all cellular?
It's Wi-Fi.
It's Wi-Fi. Okay, so
Right.
it is actually somewhat based on the DSRC, which is kind of Wi-Fi. It's not really Wi-Fi based because it's not Wi-Fi at all. It's different, but it acts similarly.
Okay. So
I just have a one thing I was thinking. One way that we could use a sensor similar to like how the cars are using these sensors to not run into things, crash avoidance, is that for a certain period in the game, it's autonomous. So we program it and we don't touch anything, and we all have to, program the robot to do the different, jobs or jobs. But another thing that we could do is like if we have, because last game there were a lot of like poles, like Mr. Stefanski said, and we could kind of use the sensors to like avoid the poles. Maybe that's
yes, actually, yeah. If there were poles in the way, it could actually sense them with the sensors and see that it's there and actually move around them autonomously. Yeah, so that would be good.
one of the sensors is one of the distance sensors. It's is a laser sensor. It's the only one that's legal for our league. The only laser device that's legal for our league. But it is a laser-based distance sensor. So, at which point it becomes very similar, right? Because laser is one of the mechanisms that is
one of
used
the
in
mechanisms. Yep. Yeah. So yeah, it can actually be used in a similar way then to guide your vehicle, which is your robot.
Any other questions? What do you guys think so far?
Hi, I had a question. How much of your time is used in programming versus how much time you would use maybe doing like research with hands-on, with the actual equipment?
Okay. I would say almost equal. And the reason why for me almost equal is because I am actually one of the programmers. So we have 2 programmers on our team, and the rest are really not programmers. They are more hands-on and more test-driven, but I'm also doing testing. So, but I don't do a lot of the actual like I wouldn't be actually doing the soldering on the device. We already have our hardware done. Now we're just working on the software part of it. So that's kind of why it's half and half right now for me, because it's more software based at this point in the development than it is hardware based. But it was very hardware based at the beginning. and also trying to make things like, okay, this works now, but it's this big and that's too big. And we need to make it smaller, or we need to have it be constrained to a certain power supply, or it needs to, it has to be in an enclosure that is waterproof and all this stuff, and have proper antennas and all this, so, but all of the hardware is almost completely done on this project at this point. Like I said, I came in kind of late on the project. They've been working on it for the last 3 years. I've just stepped in. But yeah, it's about half and half right now. Typically, I would say there's more hardware and less software with this kind of thing, because you're testing out what's going to work best at first, and then the software, you need to start to fine tune that. So, it just depends on what phase you're in the development. So,
Thank you.
This is this is just a kind of a, I don't know, off topic, I guess. Is there anything that you can think of that was kind of like a challenge that you had to kind of overcome in your job that was kind of difficult with all this?
it was very difficult switching from space physics and dealing with a computer or satellite data and switching over to automotive and cellular communication. They of course saw it as, oh, well, it's just another form of communication. It's a totally different form of communication. So it was a steep learning curve at first, and that was actually a little daunting. So the first year that I actually worked for Denso, I don't really think they got the value out of me that they could have. But now they're reaping some benefits. But it just took a while. That first year is always the hardest. A lot of people, when they first start a job, they think, oh, I've got to get up and running as soon as possible. And, they can make mistakes then. That would be one thing that I would caution people on, is that when you first start a job, you're not expected to know anything. You should be asking questions at all times. There is no dumb answer or no dumb question, because this is all new to you. So it's just kind of like what your teachers have said for ages. There are no dumb questions. Just keep asking, and eventually you'll start getting it. Because it does take a while for things to sink in at first. That was the biggest challenge, though, was actually switching careers from more of an academic-based, situation into more of a corporate-based situation. So yeah, that was, I think, my biggest challenge. And that was back in 2015. So I passed that now.
Got it. Thank you.
Yeah.
This is kind of the converse of the question, but is there something that like you enjoyed more in the job? Like, is there a favorite part of the job that you like doing?
I actually like doing the visualization displays, and I think that's why I did such a good job on the one that I wanted to do just for myself, and then other people took off with it. Like I said, it's even being used in Australia and India, and so it just I just like dealing or like looking at how I can incorporate different data together instead of just looking at just this. Okay, here's where it is. All right, and here's how the the signal is. You can plot that versus time, but to be able to put it on top of where you were at the time is very nice. So I always enjoyed kind of doing visualization of data. Even on my previous job, that was my main job, was if you look at the data here, there's a quick look plots and stuff that we did. I did this. Yeah, I even built this whole calendar app because there was nothing like this. But there's viewing geometry. Like, this is actually the path of the the path of the satellite as it goes through. This is one viewing angle and another viewing angle, and then where the sun is where that dot is. And so there's different things that you can look at, like winds and vector winds. So this one I really like, is because you can see as you progress through the days how the winds change in the upper atmosphere. This is not climate data. This is more of it's not really space weather either, because it's not quite in the solar. It's still in it's like in the ionosphere mesospheric area. And I don't know if you know what it's like, troposphere. Troposphere. Now I can't even think of it. But it's like, then it's mesosphere and stratosphere, and the ionosphere is in the mesosphere also, which ionosphere just means that there's active particles there, and that's where you get aurora. But yeah, so but yeah, so this is, that I just liked visualizing the data, because nobody had anything like this for any of the from any of the other satellites. And so it was kind of nice to be able to provide this to scientists. That's why there's so many publications using this data. But yeah, so I don't know. Like I said, I just like even just this, where I just showed, where when data got processed, well, there's some areas where there is no data for those days, particular type of data for those days. And And that's what this is supposed to show. There is a legend here somewhere, but I don't know where it is at this point. Oh, that's the previous one. Oh well. So
do you know
here it
who's
is.
maintaining all of this?
Well, okay, that falls on Rick Nijinsky. He's a Canadian scientist who actually got the inevitable oh gosh, I don't know, is a position that I would have liked too, but he actually looks over this. He produces lots of different papers on this also, and yeah, so this kind of thing though is not looked after. This is an automatic process, meaning like there's a computer and it just every day it kicks off and runs over this data. So I could possibly like go online or go on there and rerun it for this section of data here at the start of 2017 that looks like it's missing, and it probably could fill it in. I don't know. But this is an automatic process. I basically, since I knew the funding was running out, and because NASA and National Science Foundation grants were drying up, we wanted to make sure that this data would be available for scientists for many years to come. And I actually stopped working on it back in 2015. So it's since 2015. This is just an automatic process. That's why it's all squinched in here, and all, it's just because every year it just adds another one, and so it just it'll keep getting smaller and smaller until I don't know, until it's totally unreadable. But yeah, nobody is looking after this anymore, which is kind of sad. But at least it is still available. You can get the data, download it, and actually use it in whatever paper they want.
As an IT infrastructure guy, that reminds me of the anecdotes about the old Novell servers that people had forgotten about, and they just kept chugging away and doing their job, and all of a sudden the boarded up closet that nobody knew was there anymore started beeping.
It actually didn't have a door anymore.
Right, it had been boarded up like 3 years ago, and nobody even knew it was still in there. But because it was just chugging away, it's one of those kinds of things.
And I know for a fact this is actually a desktop computer that is sitting on Dr. Nijinsky's desk, and I know it's just sitting right there, and it's just chugging away, producing what it needs to produce.
That's great, but that's good work, right? Things that last like that are good work.
Exactly, and I'm very happy that after all these years, it's still working. I occasionally just go back on the website and just go, wow, it's still there. So kind of interesting.
So here's a question. A little surprised one of the students didn't ask this. What programming languages do you use? Why? And what do you like best?
Oh my gosh. Okay. So I am very old school. I have used, especially for all this, the academic stuff, it was almost solely Fortran, because that's what the scientists I work with knew, and Perl scripts. So that's like really old school. All the new stuff is done in either Python or C#. I enjoy both of them for different reasons. Python is sometimes just the best way to get something done. And other times, though, you really want to have a more full-featured, programming language. Well, Python's pretty good. I mean, there's lots of different modules that you can install too, and all that will help. But like C#, I just, if I'm going to be doing a program that is Windows based and it has lots of little, GUI, or whatever, I'm going to use C#. It's so much easier to use. I also use Visual Studio in order to program C# because it has built-in features that are great for debugging whatever you need. But Python is awesome. I would say that that's a great base language to know and understand.
How about Java? You ever do any Java?
I love Java too, but I don't like it for a lot of things. And it comes down to it comes down to my bias, I think,
Sure.
because Java can be run on anything. I mean, Python can be run on anything too, but Java is it's sort of C-like, but not C-like. It's kind of its own language, not really. I mean, it's kind of. I think I got introduced to it at the wrong time. But that's just a personal preference.
Sure.
So, but there is actually JavaScript on my old web page, which I think is funny. I don't think anybody even knows what JavaScript is anymore, but
Aiden knows. Aiden knows now. Aiden's one of our students.
okay.
Sorry,
So,
that's a
yeah.
bit of an inside joke.
Okay.
He was asked once by a judge at a competition what programming language we use for the robot, and he said JavaScript. The answer was Java.
Right.
We use Android Studio.
Okay. I
As
like Android
opposed,
Studio. It's very similar to Visual Studio.
yeah. So that's what we use as opposed to blocks or some of the other other things that are available.
I think that's actually better to use something like that because it's more of what is actually done in the business world, truly. I mean, like if you're going to get a job and you have, hey, I've got some programming background, that's going to be more, marketable.
Any other questions while we've got her?
I can't think of any at the moment. It may hit me as soon as we leave the call. Like,
That's fine.
Usually does. Okay. Well, we just have a couple more minutes.
Patrick's got an inside track to me, so he can always pass a question along if you really want it answered.
Got it. It may happen, and then I'll be like, "Gosh darn."
So with students so our students, we have a really young team. We had we've only got 5 students on the team this year, or had this past year. We don't know what's going to happen recruiting wise for next year, but so far we have 5. We had 2 returning students. They were both sophomores and had been the we just do what the older kids tell us to do students. Younger
guidance.
siblings and whatnot. Just 2 that were returning, and the rest of the team graduated. So that was going to be it, and they rounded up 3 more younger siblings and friends, 3 7th graders. So it's a younger team than I think we've ever had. And they did phenomenally well. They really picked it up as far as leadership and organization, and they've done a great job. So, but they got a couple more years. They're still a young team, and they're really just now starting to think about what do I want to do when I grow up, kind of, right? I mean, so for students in that position, do you have any suggestions as far as what to look at, what things to consider, or if they want to go into STEM fields, if they want to go into science or into engineering, what are the kinds of things that they might think about or look at?
I say look at internships, look at these summer programs that people run for, like I said, the research experiences for undergrads. There are things like that with almost every university. They're sometimes harder to find, but there's programs out there. Sometimes they don't pay at all. Sometimes they pay actually a little bit. My research experiences did pay me a little bit, which was nice because it paid for me to be able to stay in Ann Arbor and eat, so that was good. Not much more than that, but that was it. But don't be afraid to try something that's also doesn't make any money at all if you can do that, because the amount of stuff that you learn, just what you might like and what you don't like. is very good. My research experience for undergrads, I found out that I actually very much enjoyed an academic situation. I loved looking at it from a research perspective rather than from a business money-making perspective. So for me, that was the biggest driver in me continuing my education, going on to get my master's degree, and then actually even continuing to stay at the university and doing more research there. But I this is the time to do it. This is, is when you're young, is when you can, take a chance and go, nope, I guess that wasn't for me, and then backtrack and go another direction. It's much easier to do that rather than, oh shoot, I went full force and now I'm 30 and I want to change. I have a coworker who he wanted to be a lawyer and he became a lawyer, and now he's an engineer. So he did not like being a lawyer after he actually went through all the work and became a lawyer. And actually engineering was his love. He actually did lots of little hobbies. And so he actually decided to make his career, match his hobby. And so he went back to school and became an engineer. And he was 35 graduating as an engineer. So it's quite interesting. And he's one of the best engineers we have, by the way. He's excellent.
It's always great doing what you love for
Exactly.
a living.
And that, I think, is the best thing. If you know that you like what you're doing, you're going to be good at it. People are going to see that you have a passion for it, and they're going to want you on their team. They're going to want you, doing business for them. But if you are just going through the motions, and all, people are going to see that too. So you really need to, experiment now, see what you like, and follow what actually makes you happy. For me, I loved figuring out how things worked and how, different systems, interacted with each other. And so that's why physics was like the main thing for me. But then when I went into the research experiences for undergrad, I got to see that more of an applied physics. And I loved it. That was even more enjoyable for me. So, and now I'm even doing more of an applied physics, which is engineering. And so it's actually working out for me.
Cool. Thank you.
Any other questions before we wrap up?
Not that I can think of.
Well, thank you for being attentive. That was very nice.
So thank you very much. Thank you all the participants for being here, and we will talk to you all very soon.
All right. Thank you.
Yes, thank you so much.
Yep. Bye.
Thank you.